And we're live. So, hi, we'll just do quick introductions. I'm Griff Green from Giveth, researching the scaling options for Ethereum, specifically focused on, of course, scaling my own project, Giveth. And I'm here with David from OmiseGo. David, you want to introduce yourself?
Hey, my name's David. I'm jazzed to be here.
Yeah, awesome. David, where are you joining us from?
I'm joining you from a dentist's office right in the heart of Bangkok, Thailand.
Yeah, it's funny because I've been in Thailand for the last few of these, so it's nice to have switched places. Now I'm in Barcelona. But anyway, let's dive in. I just want to start out saying a little bit about our audience. They're competent. We're assuming a very highly technical audience. They're competent devs working on their own dApp in the Ethereum space. They're looking to use a sidechain as part of their launch strategy, and they want to launch as soon as possible. They've been working on this for a while. They might not understand all of the infrastructure behind Ethereum development, because honestly, who does? But they have been diving in for a while, and they're not rookies, right?
Mm-hmm.
So you guys have a lot of things going on with OmiseGo. You have huge goals of basically unbanking the banked, which is really cool. But while you're at it, you're pioneering plasma research, which is where a lot of this bridge tech is probably headed. So the purpose of this interview is really to take a deep dive into your current MVP and the current status of your technology, especially your thoughts on what dApp developers might be able to use in the next 6 months. So let's just start on that. Like, first off, what kind of dApps do you think are the best suited to use the stuff that you're working on? And realistically, when can people start implementing a dApp on a Plasma chain?
Okay, so the Plasma is huge. And kind of the big picture vision is being able to track a general state machine. So basically a Turing-complete language on another chain. That's still in the works. But what's ready now is basically tracking specific applications. So if you have an app with a specific interface that you can detail and don't need the flexibility of a Turing-complete language, I would say that's really where Plasma can shine in its current MVP state.
So does that chain not have a full EVM attached to it then? Is that what you mean?
Yeah, that's exactly what I mean. So the Plasma chain in its current state doesn't have an EVM. It just has the app-specific functionality. In the case of the bare bones MVP, that's just supporting UTXO payments, but it can be expounded upon to kind of fit a given application.
Okay, can you talk about why you chose the UTXO model instead of the account-based system?
100%. So with account accesses, basically to be able to prove an account state, the simplest way is to basically take every kind of transaction that either subtracts or adds to the account balance, and that can end up being a lot of transactions. And then you basically have to put all of them to Ethereum. Whereas with UTXOs, because they're basically finite, you can basically prove a given state or a given balance with a single transaction. And so when you're depositing or exiting, you basically only need to submit that single transaction to prove at X time you had X money.
Yeah, you explained this really well in the talk that you gave in the decentralized workshop, decentralized exchange workshop, and I linked that down below. It's the first link in the comments section here. So hopefully people can listen to that, and then this talk will make more sense. I kind of see this as the addendum to that talk. I meant to mention that at the beginning. Yeah. So you call your chains in Plasma child chains, right? Because they're born out of the root chain and in some ways subservient to the root chain. Like, can you give us kind of an overview of how you imagine these chains working? I assume the root chain is the parent chain, which is Ethereum, and the child chain is some kind of POA chain with UTXOs, maybe.
100%. You're killing it, Griff.
Okay.
So yeah, in the MVP, the root chain and the parent chain are synonymous just because right now we're only dealing with one child chain, but down the road, the root chain will be kind of the final layer of security. In our case, it'll be Ethereum. And then you can have multiple parent chains because parent chains are more of a relative term. Just as you start stacking child chains on child chains on child chains, then you start having different kind of child-parent relationships. So that's that. And the reason they're called child chains is because the child chains derive their security from their parents. In the case of the MVP, the child chain is deriving its security directly from Ethereum. So if anything goes bad on a given child chain, people can basically prove a given state on Ethereum and retrieve their funds.
Very cool. So Mark Stanwyck is asking, how far out is a working implementation of the MVP?
I would say very soon. I would say that at least what we're focusing on right now is kind of taking Plasma MVP and then extending it forward, because what we want to take to production will we'll start with the Plasma MVP, but then we'll also want to add on a lot of kind of functionality on top of that. So we're thinking a lot about kind of forward compatibility.
Okay, very cool. And you know, the chains are really cool. They have like different models, but how does the bridge work? Like, how are the smart contracts structured on each side of the bridge?
Yeah, so the way it's set up right now is that there's a root chain smart contract on Ethereum that basically secures a given child chain. And the child chain doesn't actually have smart contracts. The functionality is built in at the infrastructure level of the child chain, which is a lot simpler to track because, yeah, as soon as you get into opcodes, there's just so much more computation possible, just an incredible, so much more complexity. But with easiest example, Plasma MVP, just tracking UTXO payments, there's basically one transaction format for the child chain. And so that's much easier to track.
Oh, yeah, for sure. Okay, that's kind of interesting. So it sounds almost like this is kind of a state channel solution, right? Like you move value to this off-chain thing where you do a bunch of value transactions, and then you end up with, okay, here's you know, the solution. Now give me real ether.
Yeah, I would say there are some significant differences. But first, I have a question for you. What is off-chain and on-chain? Because I've thought about this a bit. Is on-chain in this context Ethereum, and then anything else like a child chain is a blockchain? Is that off-chain then if it's not Ethereum?
I mean, that's a really interesting thing. Yeah, I guess it is on-chain. It's the thing is, at least where it's different in my mind, is you're kind of using someone else's system, right? It's this POA network that you kind of have to trust the people that are running it. And you know, well, with Plasma and its exit strategy, you don't so much, which is pretty cool. And to me, I feel that's at least in application fairly similar to what you do with state channels, where like technically, you know, you don't really have to trust the people that are creating their state channel. You can just like, you have all these transactions and you're holding the ability to exit whenever you want. And so while the infrastructure is definitely different than state channels, it seems like the same kind of dApps that might consider using a state channel solution would actually be more suited to using the Plasma MVP than maybe a dApp that wants to use a sidechain that has an EVM specifically.
Yeah, right now I would definitely say that's the case. I would argue that for most dApps, you can build your functionality in at kind of the infrastructure level. Very few kind of dApps are complex enough that you actually need basically a Turing complete language. Yeah, it really depends kind of what you're looking for. For me, the appeal of Plasma is that it's a lot more kind of like where it will be going is a lot more general purpose.
That's really interesting. So basically, if you want to use Plasma MVP right now, you could just, create your own blockchain that does exactly what your app needs, and then that's it.
Yeah, exactly. Which for most projects will be good enough. But just like the scaling pinnacle is basically EVMs within EVMs within EVMs.
Yeah, EVMs all the way down.
All the way.
Okay, so you actually seeded me with some questions, and so I'm gonna ask them. How are you dealing with requiring two signatures that are at least 15 seconds apart, especially from a UX perspective?
So there are kind of multiple ways.
Wait, can we get background on that? Why do you need two signatures that are 15 seconds apart?
100%. So in the Plasma MVP, you basically would send a transaction and you need to sign that, but then you'd also send a confirmation. And what that confirmation is saying is that the transaction you sent previously has been successfully added to the child chain, and that child chain block has been submitted to the root chain and is valid. And this is super important for a bunch of reasons. The easiest example of why it's important is if you didn't have confirmations and just tried to use straight transactions, if the operator is a bad actor, say Alice sends a transaction to Bob, sending him $5 or 5 ETH, then the operator basically withholds the transaction. And then at that point, the operator can start publishing and exiting invalid transactions. And Alice has no way to exit, because if she tries to exit, the operator can submit proof of a double spend on the root chain, because she did essentially spend it on the child chain. It was just never included. And Bob can't exit because the transaction was never included in the child chain. So he has nothing to reference. And so, yeah. But with confirmations, basically, up until Alice sends the confirmation, she can exit. And then as soon as Bob gets the confirmation, he can exit. So yeah, it's a way of kind of handling that safely. Does that make a little sense?
Cool. Oh yeah, totally. And then how do you deal with that in the UX?
Okay, so there are kind of a few ways we can do it. We've been thinking about it a lot. So one way, so you can kind of delegate confirmations, which is doable and it helps on the UX side, but it's not. I'm not a huge fan of it, because trusting other people, like, it's a bummer. We're trying to build trustless systems. Yeah. The other way is just kind of basically having it in the background. So like basically building a browser extension so that confirmation happens from the client, but the user doesn't have to keep a given page open. They just have to keep their browser open, which is better, but it's still not optimal. And then the ongoing research is actually basically adding more rules into kind of the mix and trying to eliminate confirmations. So yeah, that's the solution I'm more pumped about. Yeah. But right now it's here. We need to chop it down. And
yeah, well, hey, you got to reduce scope for the MVP. So, 2 confirmations right now, not the perfect. Yeah. That's okay. What kind of UX do you actually have? Like, what kind of dApp are you building as a preliminary dApp?
Yeah. So right now, the majority of my focus is kind of at the base infrastructure level, but we're making the OMG network, and the goal is for us and other people to build on the OMG network. So we're currently kind of prototyping some potential dApps that could basically, like some forward-facing dApps that could run on a Plasma chain to kind of show the functionality and what that would look like. Because right now, no one's really familiar with what it would look like to build on top of a Plasma chain.
Of course. I mean,
Yeah.
plasma is just a cool word. It really doesn't mean anything that other than that to me. Like it's kind of this big mystery. But so okay, here's another question you seeded me with that I think follows well. In these dApps, like when there is a general state transition coming to child chains, what complexities come along with tracking them?
So a lot of complexities come just because there's so many different things that can go wrong, and the amount of computation that has to be done is just so much more. So I would say the greatest complexity is probably tracking where exactly things have gone wrong, and that itself is doable in most cases. But just there's so many edge cases that can occur, and yeah, right now we're still like the focus, at least for me, is still on like messing with Merkles and playing with state roots. But yeah, going forward, we're looking into other cryptographic techniques as well to basically better compact state and to be able to prove what went wrong and where it went wrong on a parent chain.
Man, Ralph Merkle is a real hero. I just gotta say, that guy,
he's the real G.
Really, I mean that guy just made so much magic happen. It's incredible.
Yeah,
we're all living off of that. Like he does not get enough credit in the space. Let's see. So, are there? You said that you have some preliminary dApps that you're trying to push or like trying to implement. Are there other teams that OMG is working with, or are they all internal to OmiseGo?
So we're currently basically looking to collaborate. It's still early enough that right now we're kind of still defining exactly what the endpoints will look like. And so kind of what down the road, what that'll look like is we'll kind of solidify this the spec and and then from there we can basically work on getting the infrastructure level to production, but we'll also be able to release endpoints publicly so that people can start building on top of us, basically.
What do you mean an endpoint? Like, what's that mean?
Endpoint? So when I say endpoint, I basically mean something that people can hit. So like most likely a certain X format that people will have to formulate and sign their transactions before they send it to a plasma chain. And if they don't meet that format, it just won't work because that's what it's expecting. So once we kind of clearly define the endpoints, basically the given transactions accepted, the given functionality for the V1, then people will be able to kind of even preemptively start to build on top and take advantage of Plasma.
Interesting.
Yeah.
So on that bridge, how does the UTXO bridge, like the child chain, send information back to the Ethereum chain? Like, because it has to plant its like Merkle root in a smart contract, right?
Yeah, 100%. So right now, for the Plasma MVP, what gets sent back to the root chain is just the hash, and that hash is, as you stated, the Merkle root of all the transactions in a given block. So that basically, from that, you're able to prove all the UTXOs spent and created in a given block. And so every time a block is created, right now, because it's POA, the operator basically submits that hash to the root chain, and then everyone who has value on the child chain can basically verify that that's correct. If that hash is wrong, or if they can't get the information to verify it, they need to exit ASAP.
So is there a gas? How much do you estimate the gas cost to be for the operator every block?
Oh, it's not that expensive at all. We're still playing around with it a bit in terms of optimizations, but it should not be more than like a few thousand max.
So like a regular transaction is 21,000. It's like maybe 50 or less.
I would ballpark it at 100, but we're still running optimizations on it. So yeah.
Okay. Okay. And so 100,000 gas every block basically is the cost
Yeah.
for the operator ish.
Yeah. Yeah. And that's not too bad.
Not at all.
Just because basically the way the blocks are set up right now, at least, we're using a fixed Merkle tree. So if we want to make them bigger, you just kind of add a layer of depth on the Merkle, and all of a sudden you have twice as many transactions. The real issue with that kind of side of scaling is that we want people to actually be able to hold and run the child chains and like verify them. And as soon as you start having these crazy huge blocks with a bunch of transactions, bunch of UTXOs, yeah, my laptop might struggle.
Yeah. I mean, hey, well, a Bitcoin block is every 10 minutes, so there's lots of transactions going through. It seems to work. It can probably work for a gap. Well, okay, let's talk. Let's get real, right? Let's say Giveth wants to build our own plasma chain, because we do. Oh yeah. And
oh yeah.
I mean, that would be pretty exciting. And right now we're on Rinkeby testnet. I already kind of explained to you off before the call kind of what we do. And I'm curious, where would we start? You know, how do we as a DApp build our own blockchain that will model liquid pledging? And then, yeah, just can we walk through the steps of how I would do it?
Yeah, definitely. So I would say the first step is understanding kind of Plasma MVP, if that's kind of what you're gonna go off of, which I would recommend, because that's kind of it's the now solution. General state transitions are soon.
Yeah.
So yeah, really understanding Plasma MVP, and then from there thinking about how you can extend it for your specific use case. So a lot of the principles, like easy one, is kind of right with Plasma MVP. You're doing prepares and commits, and that is like that's where it gets its security. And also, like Plasma MVP uses a priority queue for exits, and so taking those ideas, and a lot of them are still relevant for a lot of different applications. For liquid pledging, like you'd still probably want to have deposit functionality, right? And then, but from there, you basically build in the other functionality on the child chain, and then you'd only take it back to the root chain when you basically want to give it to someone, like give the money or value to someone outside of the system. So if you got the people who you're giving the value to on the child chains, you could basically create a whole ecosystem on a Plasma chain, which would be awesome, because the transaction throughput, then people would deposit. But as long as everything works, it would stay on the child chain.
Yeah. I guess that's one of the big issues, is that if there is an authority, I mean, I guess but for a DApp, it doesn't matter, because the authority is the DApp team usually, right? Or that's how you would envision it. And so if there's a problem and the DApp team is dishonest, well, yeah, everyone exits the chain and escapes, and the DApp is over. But of course it's over if the DApp team is dishonest.
Yeah, that's definitely true. I would say, like, right now, proof of authority is good because it's now, but transitioning to proof of stake is not insane in terms of like having a proof of stake contract on the root chain, maybe something along the lines of Casper FFG running as the consensus mechanism, and just kind of following that on the child chain. And so I definitely would advocate for like V0, V1 proof of authority, but then switching to proof of stake ASAP, because you're right, for dApps, if the dApp team is dishonest, it's horrible. But there's a lot of ways that to kind of people can get really creative, especially if they control the consensus mechanism, in terms of like quietly screwing people over and like just fiddling with things just a little. And so yeah, it's still scary. Yeah.
I mean, and how do you expect people to check, right? Like they're running their own node or something? Like you have to have people run a node to use your dApp effectively?
Okay, so realistically, we want people to actually use child chains, and so everyone running a node, they can do that if they'll basically have the option to kind of like run the child chain and validate it, but they can also trust other parties to do that if they so desire. So what's key for us is basically offering anyone who's interested the optionality to check 100 and to make sure with 100% certainty that everything's correct. But we don't want to kind of force that burden upon the end user.
Yeah. Yeah, because I mean, no end user is going to want to run a node, right? That'll never happen. And
yeah.
And like even going to these websites now that are kind of running a node for you, you know, like if they're mining Monero or something, when you go to their website, like maybe you could pull off a strategy like that, but it wouldn't really make people happy every time they use their dApp that their computer starts going. Woo-hoo.
Yeah.
So,
yeah, we're definitely thinking a lot about kind of the security. I guess at least for me, what will be super key is having a certain threshold of users actually checking it, because yeah, I don't want people. OmiseGo, I am a trustworthy person, but I don't want anyone to have to count on it. Oh, I see you looking at me like that.
I don't know, David. I don't know. I haven't met you yet, so we'll see. Maybe we'll see when you get to Barcelona.
Yeah, we'll talk about our feelings, build some trust.
Yeah, exactly. But also I want to go back to trying to build, like, you know, most of the dApp teams have a Solidity system. You know, they have some kind of smart contract system. How would you take that and turn it into a UTXO blockchain?
Okay, so first with UTXOs, you're probably going to want to do account simulation. And that's basically UTXO netting. So that's where, so let's say you have Alice and Bob again. And so Alice basically keeps all her funds in a single UTXO. And then when she sends Bob, say Alice has 100, she sends Bob 5. She basically splits it up. She gets 95. So that's her new balance. Then Bob has 5. But then Bob actually does a second transaction, basically combining, say he had 10 before. So he combines his 10 and the 5. So that then he has 15. And so it's basically simulating. It's as if they had accounts. And why this is awesome, it's a lot easier for applications to deal with. And also when it comes time to exit ASAP, it's a lot cheaper and quicker to exit one UTXO that's basically your account as opposed to say 1,000. So yeah.
So the first step is to build some system that takes because when Alice has 100 in a UTXO, she sends the whole 100 to Bob and gets 95 back. And then Bob has 5, right? Like that's how the UTXO system works. No?
So when you spend when Alice creates the transaction spending 100, she basically creates 2 unspent transaction outputs, one with 95 to herself, and then one with 5 to Bob. So Alice always has custody of her funds. But yeah, that and I see that as kind of being built in behind the scenes. The end user should never have to worry about that. Yeah.
Okay. But then when Bob sends a transaction here and he gets some change, you know, and then he sends a transaction here and he gets, sorry, I think of it as change, but you're right. It's like, you know, you break it up and then you send. But sometimes, you know, if let's say Carol decided to send Bob some money too, you want to be able to smash the five UTXO, whatever, we'll call it OMG coin, right? The 5 OMG, and then like the next 5 OMG that Carol sends, you build some kind of system that just plops them together.
Squash it together, yeah.
And then everyone has just one UTXO in their account.
Yeah.
Okay.
Exactly.
And now how do I model something complex that's in a dApp in a UTXO blockchain? Like I'm just like, I have no idea how to do that.
So I would start by kind of looking at just like going through each function that you have in a Solidity smart contract. And because basically there's a good chance you can kind of put that functionality into the child chain, but at the infrastructure level as opposed to the smart contract level. So basically taking a Solidity smart contract and basically building the child chain infrastructure around that single, or like that a group of smart contracts if you're dealing with multiple ones in your dApp.
So it'd be like, I don't know, I'm trying to think of this in Bitcoin, because Bitcoin's the UTXO structure item, right? And maybe they have, like, in the client, they have some cool things like child pays the parent. And that's kind of something that you could model on a smart contract, but they have it in the client. And is that basically what you would do? You take functions in your Solidity contract and put it in the clients that are running the child chain?
Yeah. Essentially, yes. So for some, you'd add like rules basically for the child chain. And then for, like, I would say that an easy example would be modeling an ERC20 token on a child chain. So basically, Plasma MVP with like, by just adding a currency field, you can support ERC20 tokens as well as Ether, which is cool. But if you wanted to create an ERC20 on a child chain, you could basically build that functionality in. So for a given fee, people would basically send X information. Maybe it's like symbol and like all the kind of config stuff for an ERC20. They send that to a child chain, and then that gets created on the child chain. And then from then on, that basically becomes a valid symbol for transactions, like typical Plasma MVP transactions on a child chain. Or another example would be like if you want to add in burn functionality to a child chain. Sure, you could just send your UTXOs to like a 0 address or some random address. That's one way. But you could also implement burn functionality. So like basically just like in the infrastructure, JSON RPC, people would call burn with X information, sig, and then boom, you have burn. And that's it at a super simple level, but you can kind of become increasingly complex from there.
Interesting. Okay. So that's making sense. Now the challenge here is that if you build your own chain, you kind of have to build your own block explorer and a lot of the infrastructure around that. Is that?
Yeah, we're 100% thinking about that. So yeah, right now there's some solid block explorers for Ethereum, but given that Plasma is a baby, there are no block explorers for it. So yeah, that's definitely something we're thinking a lot about, because if people are relying on the child chains, they basically need to be able to see the status of a given child chain at any time. I basically the way to deal with this, I see it as standardization, because as soon as you start dealing with a bunch of app-specific child chains, there's a very real danger of each project having to not only handle a Plasma chain, but also handling all the tooling that you want for a blockchain. And so as kind of the research moves forward, I'm really hoping that there's kind of like a certain standard for interacting and getting information from Plasma chains.
Yeah, I mean, if you say that there's a lot of good block explorers for Ethereum, but there's not. So there's only one. It's Etherscan, and it's actually a big issue for all these side chains, because there's no options. There's no other, like, Etherscan's not open source, so any side chain right now has to figure out how do we show people what's going on our chain. And that's especially when when everything's in alpha, you shouldn't trust the dApp itself. So you need that second layer of verification. So I don't know, that seems like a real challenge to me. If you have, at least for the MVP, if you have somebody trying to build an app specific chain, wow, yeah, I don't know how you would generalize. Like what we do for liquid pledging is totally different than what a decentralized exchange would need to do. Like, so I don't know. That'll be an adventure.
It will be a huge adventure, I guess. Yeah, I may, yeah. In terms of Ethereum explorers, I guess I'm more meant they exist, as opposed to Plasma Chain explorers, which do not exist.
Yeah.
But yeah, it'll be a super interesting path. I think for like MVP type stuff, it'd be great if people had like a nice way to view it in the browser, but it's not critical to functioning. And the main focus is that people are able to basically run and validate the child chain, because that's kind of what security relies on, because then they'll be able to challenge and exit. And right now, a block explorer is kind of future.
Yeah. Yeah. Well, that's really cool. And the other big piece is doing an exchange, because it sounds like something you could do, which is cool, is kind of what POA Network did with these cross-chain crowd sales, where you actually make your currency like native to this child chain, and you just have like your deposit function on the main chain is effectively an ICO. And then all of a sudden you have this chain that's built underneath it that relies on Ethereum for its security, but boom, here's your currency. Problem with that is that then how do you trade your currency, right?
Yeah,
and that's where OMG comes in, I take it.
Yeah, yeah. So liquidity is definitely something we're thinking about, and because for trading to occur, liquidity needs to be plentiful. And so, yeah, that's definitely something we're thinking about, because it's a little more complex, just because people have to kind of enter the world of Plasma and child chains before to kind of trade, basically.
Okay. Yeah. So now let's go to the audience. I feel like I run out of questions, although this is really good stuff. So thank you so much for answering all my tough questions. Let's see. So we have Majco is very interested in specifically things that have to do with OmiseGo. So I'm going to kind of skip those questions. Because this is not an OMG pump fest. No offense.
It's fine. There are enough of those.
Yeah, exactly. So how about another one from Mark Stanwyck? Can you talk more about the POA security of the MVP as it relates specifically to OmiseGo?
So it's pretty much basically POA. Not optimal in terms of consensus, but in terms of kind of getting something out there, it's the least complex. And we're basically, by doing POA, it doesn't have the sturdiness of POS mechanism, but it doesn't decrease security, in the sense that people, if anything goes wrong, even if like OmiseGo was running the POA chain and they tried to act badly for whatever reason, basically they couldn't do anything, as long as other people are basically validating the child chain. And as soon as the operator does something bad, then you exit within a given amount of time.
And that means that you have to be online checking, right? Like within that 7 days kind of a thing.
Yes, exactly. You have to check, or there's basically ways to set it up so that someone you trust can basically exit for you. So this is basically not giving anyone else access to your funds, but giving someone else access to basically leaving the child chain for you, if you're not interested in checking the child chain every 7 days.
I think that's a good delegate model for sure. That's delegate.
It doesn't really sacrifice security that much, and yeah, from a UI perspective.
Yeah, I mean, the worst case scenario is that everything's fine and you exit anyway, right? Like,
yeah.
So, okay, and now we have ePhone Dev, who's asking about Tendermint Plasma. Will they run in parallel for some time? Do you start with Tendermint and then migrate to Plasma, or what is the relationship between Tendermint and Plasma?
Yeah, Tendermint's super cool, super versatile. The way things are currently set up now is that a Plasma team is being kind of it's evolving in Bangkok. And then we also have a blockchain team in Poland, which is working on Hante. Yeah.
Hante?
Yes.
Hante.
Oh,
okay.
Hante, which is basically a tendermint based exchange.
Oh, okay.
Yeah.
Okay, so you have a Tendermint plasma team in Bangkok, and they're going to eventually transition the POA to a Tendermint, or?
Right now, we're still playing around with kind of the potential interaction between the two. Right now, the focus in Bangkok is kind of evolving the plasma specification and getting that formalized.
And Tendermint, I know in the calls, in the plasma calls, Tendermint's there, Cosmos, and then you guys are there. Are they doing their own plasma research? Do they have their own team that's separate from you guys, and you just collaborate?
Yeah. So everyone on the call is kind of, at least for now, doing kind of their own thing. And then the calls are a wonderful opportunity where we can kind of put our heads together and learn from kind of the different niches that each project is carving out.
Okay. So let's see what Elmar Devar has to say. They're saying, what will be the minimum fee a validator can set? Is it flat or percent based or tiered? I don't know. What is the role of a validator?
So this is for OMG staking tokens, proof of stake.
Oh.
It is not directly related to scaling.
Elmar got me. I was trying to skip the OMG token. You can answer it. It's been asked.
I would say it's an area of active research. Basically, for different use cases, it makes sense to kind of do both, essentially, because yeah.
Okay.
I don't want to say too much before.
Okay, that's fine.
Before it's ready.
I'm going to answer this one from Eon Love. We'll kind of divert it because Eon Love wants you to explain Merkle tree and why it helps Plasma OMG project. And what I would say, Eon, is that Grid Plus actually wrote an incredible description of how Merkle trees work. And if you read that article and then watch David talk in the Decentralized Exchange workshop, which I linked down below. It's the first link in the thing. I think with those two resources, you will have a complete understanding better than any of us can do with words. So those multimedia resources will help you a lot. Let's see. How about Mark Stanwyck has the best questions. How would yeah, he's awesome, man. Keep asking questions, Mark. How would the average user actually go about validating the POA chain? What does that look like?
So it basically, right now we're calling it like a child chain status tracker. So they'd basically run a program and basically be pinging the child chain, basically endpoints, so like API endpoints, to basically get the information they need to validate each block. So basically checking each transaction to make sure it has the necessary signatures, checking for double spends, all that stuff. And then if everything is good, up until kind of where they have information, then they are basically safe to use it. If anything's wrong, exit.
So they need to be watching the smart contract on Ethereum and be validating the blocks, basically.
Yes, exactly. They basically validating the child chain blocks is awesome, but if another hash gets submitted to Ethereum, because the hashes that are submitted to Ethereum are what are basically used to prove who owned what at a given time, it's super important that those match the child chain blocks.
Okay, and then ePhone Dev, who also asked great questions, is just checking in with, like, does Plasma require Casper or sharding to be finished on Ether?
No, it does not. The way I kind of think about it is that they're super complementary. Yeah, but they don't require each other. And so they're both kind of progressing forward. And with like sharding and plasma, they'll just the scaling potential is nearly endless.
Infinite. No, I'm just kidding. Someone gave someone some crap for saying that infinite scaling was possible.
Infinite's a scary word.
Infinite is a scary word. Okay. Well, I think that's all the questions I have. Oh, wait, one more. Mark Stanwyck did come through with something.
Keep it up.
Yeah, Mark. Seeing as how these scaling issues are yet to be solved and are so important, do you ever feel overwhelmed with their size and scope? Oh, going straight to the heart.
Yeah. So this is a bit of a call to action. From an outsider's perspective, at least when I was an outsider, I kind of thought that everything was being worked on by like huge teams and like everything was super organized and like these super important problems with lots of money on the line had like a bunch of organized people constantly working on solutions. And this is not the case. I hate to break it to everyone out there. People are working very hard on solutions, but there can always be more people. There are so many different problem spaces involving scaling and other kind of blockchain problems that need to be researched, solutions that are waiting to be found. So yeah, overwhelmed sometimes, but join in and I will feel less overwhelmed and we might solve some big problems a little quicker.
Yeah, join the scaling party. In fact, we're having a scaling party. We're having a few parties in Barcelona, and I believe you're going to make it, right?
Yes.
Yes.
100%.
100%. I like that. And so we're going to do an event on the 5th that is really just for the scaling solutions, people who have actual solutions, so they can do the kind of the same thing that happens with the plasma call, just kind of like that brain meld, so that you can talk to the state channels guys and you can talk to the bridge change guys. So if anyone out there actually is building a state channel or a bridge chain solution or any other scaling solution, definitely reach out to me so that I can get you into the 5th. That's very strongly invite only. But then on the 6th, DApp teams are welcome to come and interact with the scaling solution teams. So like if someone who's watching this call really wanted to start working on the MVP plasma, they could come and talk to you. You'll have your own little table and they could ask you, hey, like, what do I need to do?
I get a table?
Yeah, we're going to give you a table. It's a rental.
Okay. Oh, can't keep it. Okay. Thank you for telling me that now.
Yeah. It was close. I know. But then, yeah, and then we're actually doing a cool little 777 launch party as well on the night of the 6th. So, you know, after 2 days of like blowing your brain out with talking to all the geniuses about scaling, you can just like, you know, have some beers and listen to music and watch Jordy make magic happen when he launches the first 777 token. So yeah, so if you guys want to come to Barcelona, make sure to reach out to me on the ideally in the Riot channel. In the there's a link down below near the end, so you can reach out to us there. And thank you so much for. There is more questions. Let's see. Mark has one more. How can someone with a non-development background contribute to scaling research? You got.
I got this. So I would say implementation is very developer heavy. Mechanism design definitely requires like logic, but you don't necessarily need dev skills. So yeah, I would say it really depends how you learn. But just like going to events, talking to people smarter than you, reading in a bunch of papers, and kind of just at least how I think about research is you kind of have a toolkit of like some cryptographic stuff, some mechanism design stuff. And the more stuff you learn, the more cool ways you can kind of put stuff together to make stuff. And so, yeah, learning as much as possible. And you don't necessarily need to have to code anything. you can kind of just think about it more at a theoretical level, create specs and stuff.
Yeah, hey, I'm not a developer, so just I feel like I'm doing something that's helping.
Yeah,
so,
you can also bring people together.
Yeah,
like it does.
Yeah, exactly. Good old Giveth, bringing people together. Well, thank you so much for your time, David. Enjoy Thailand. I miss it already. I love Thailand so much. Glad your mouth is less numb now, and I can see that it improved from when we started this call, so that's always good. And yeah, and any last thoughts?
I'm pumped for Barcelona. It's gonna be fun.
Excellent. Okay, well, thanks, man. We'll talk to you guys later. Thanks for joining us, guys.
Bye.